Hi doctor, today we are going to present on our technical paper titled Movie Horror Scene Extraction Using Finite State Machine. I am Boon Hao and I will be presenting in the first half while my friend Yuan Hui will take over from the second half onwards. In recent years, media in the form of video has become the mainstream of communication and entertainment. Drama and movie industry are blooming more than ever, especially with the rise of streaming companies such as Netflix. For a video to become popular, attracting audience interest is the first prerequisite. To achieve this, an eye-catching trailer is a must. This is especially true in horror genre movies. For a filmmaking team, a tool to help them in identifying and extracting impactful horror scenes out of all available scenes in a particular movie would be a great help. Not only that, streaming services like Netflix can also benefit from this, making it a great use to auto-generate relevant trailers without any human intervention. As of now, not much research has been performed or done on method to extract horror scenes from a movie. In this paper, we studied several approaches which could potentially help us in achieving this and then suggest a system that utilizes all the approaches. So for our proposed solution, this is how the system block diagram looks like. The movie will have to pass through different stages until horror scene extraction is performed. The stages are shot change detection, activity intensity, scream detection, and finite state machine. The system receives a video file as input and produces horror scene as output. Firstly, shot change detection is used to separate each shot using color histogram. Activity intensity is determined for each shot using audio and motion. If a shot has high activity intensity, scream detection is applied to check for screaming. Finite state machine is used to determine whether the scene is a horror scene and then to extract the horror scene. For shot change detection, first, since a scene is comprised of one or many shots, each shot needs to be identified. Shot change detection is used to determine shot boundaries using color histogram. After the video is loaded, sequential frames are read to segregate RGB component of every frame. Then 4 blocks will be created for each of the RGB component and histogram is taken for each block. Frame difference between current and previous frame is calculated. If the frame difference is bigger, shot change point is detected. The shot will then be used for calculating activity intensity in next step. For activity intensity, it is determined using motion and audio of the movie. Let's talk about the motion part. Motion in the movie is utilized to identify scenes. Normally, the camera in the movie has translation, scaling, and rotation. All these three attributes make up the motion vector, and the vector is used to calculate motion intensity. For example, when a person is slowly approaching an unknown object, the motion intensity is low because the camera motion is relatively low and slow to create a suspense feeling. Then, when the object turns out to be a horrified creature, the motion intensity spikes because there is sudden large and quick camera action, such as chasing, escaping, and struggling.
Let's talk about the audio part. Using the same example in motion part, horror scene often starts with low audio intensity and followed by a sudden high audio intensity signal. For example, the character is slowly approaching an unknown object. At this moment, there's low audio intensity because what we often hear in the suspensive atmosphere is sound of breathing, clock ticking, and water dropping. After that, the unknown object turns out to be a scary creature. At this moment, we can hear the character screaming in horror, which contribute to the spike in audio intensity as shown in the signal image. However, other than screaming, it could be several other factors such as noise and explosion contributing to the spike in audio intensity. Hence, scream detection is used to validate high action and intensity. We will detect scream using scream sound detection with the combination of continuity of log energy detection, high pitch analysis, and compact MFCCS across frames using SVM. Log energy is adopted to detect the energy continuity of the sound to indicate screaming. Normally screaming has high pitch, which will be detected based on the autocorrelation to extract the highest pitch for each frame. Then pitch analysis is applied for a time window containing various frames. To further validate the high pitch sound as a scream, a SVM based classifier is used with the feature vector generated from the MFCCS across a window of frames. As we can see here, top rows represent the scream type high pitch sound, while the bottom row shows the non-scream type high pitch sound. As we can see here, scream type high pitch sound has sharp edges, while the non-scream type high pitch sound has dull edges. Finite state machine is used to extract the horror scene. The shot in the horror scene often has the following pattern. In the beginning, the suspense scene is observed where the shot length is long with slow motion and the activity intensity is low with low energy and high silence. That means there is low to no speech and only suspensive background. Then assume a predefined period has passed. It is followed by a sudden increase in activity intensity and scream can be detected in the audio. There are 4 states in the finite state machine. S0 is the initial state, S2 is the accept state, and S3 is the trap state. When S0 has low activity intensity, it goes to S1. When S0 has high activity intensity, it goes to S3. When S1 has high activity intensity but no scream is detected, or S1 has high activity intensity and scream is detected, but it happens before the predefined period, it goes to S3, which is a trap state. When S1 continues to have low activity intensity, it stays on the same state. When S1 has high activity intensity and scream is detected, and it happens after a period of time, it goes to S2, which is a accept state. S2 and S3 will always have transition to itself. In conclusion, finite state machine is used to extract horror scene from movie with the help of short change detection, activity intensity, and scream detection. In future, we plan to develop a finite state machine to detect 3 levels of horror, such as the gross out, horror, and terror. That's all from us. Thank you very much.